Let's see if this works. I hope it's working. It looks like it's working, yes, okay. For a moment there I thought my mic wasn't going to be working again, but we're okay. Everything's fine. Whew. Rightio. Right, what are we doing today? What did we do yesterday? Okay, let's go over what we were trying to do yesterday. So yesterday we were trying to do some stuff to do with like job planning, and then we started making another little CLI tool for building jobs, and trying to get it so it spits out a sort of list of placements and so on. And we started writing some code, and then I wanted to build a sort of tree of what it was going to spit out at the end of it. And then I did a bit of investigation off stream about potential crates that we could be using for potential crates that we could use for organising the data structures, as in creating the trees that we need, and even if we needed to create the trees, for instance. So I had to think about that, and I was going through some of that, and then I'm looking at this and going, this isn't quite right, and then I'm like, oh dear, yeah. So then I poked some things around. Anyway, let me show you some stuff, and then you can tell me what you think. So what I started coming up with yesterday was this expected job tree on the left hand side, but it's not really right. And then I sort of transitioned it to this kind of thing where, for a given sort of job, part of a job, you expect a bunch of placements for a particular design on a particular panel and so on, and it completely and utterly changed the way that you would specify all the arguments for it, and made me think about sort of like how you even reference the individual parts of the job, because on a CLI you're going to need some kind of like naming key, essentially sort of like a path kind of thing to the thing that you're talking about. And the thing that got me sort of going on this was like, how do I specify the order of the design variants on the bed of the pick and place machine that I want to place? How do I specify their order? That was where things started to unravel a little bit. And then I took a little step back from it, because I could clearly see that it was sort of just going in the wrong direction. Wrong direction. And I had a little think about things. Not that. Hold on. This. There we go. So I drew up a little sort of like word cloud, as it were, with all the different things, and some discussion on the Discord server. So I made some notes on there, and what we've got to do today is sort of try and work out how to connect all these things together. And there's quite a lot here, it turns out, which is why, I guess, I felt the initial need to create this software in the first place, right? Because the thing that was the worst thing about the other bits of software that I was using was the overall workflow. This was the worst bit, and this is what I want to get right on this. So I want to get it right in such a way that it's workable for now and workable for the future in lots of different scenarios. And it means putting a little bit of extra time in now, rather than just hacking away at some code, not blindly but prematurely, I think. So today we're going to have a little sort of mind explosion of stuff. So what I was thinking yesterday, I'll try and mark this up on here as we go along. Yeah, we'll see how we get. Is this the right pen? No, that's not the right thing, is it? That's a selection tool, Dominic. Okay, let's try this. Yeah, that works. We can draw things. Okay, great. So, where do we all start with this? Where do we start with this? We start with the EDA tool, which isn't on this list. So let's put it on this list. I think I used this color. Let's say I'll write EDA here as well. Yeah. So you start with an EDA tool. You start with a design. Great. and then you've got that's not the right colour, is it? Oh no, hold on. What's the right colour? Maybe it's this one. No. Oh wait, no, hold on. No. Oh dear. It's a disaster. I can't find the same orange that I used before. Is it this one? No. God damn it. Okay, well, you know, the next one's just going to have to do. Oh, I got the right one. Hey, happy days. E, D, A. All right. Yeah, so what we need to sort of come up with today is sort of like how to join all these things together. How to join all these things together. Other thoughts I had yesterday when I was coming up with this is that the whole sort of thing is like an iterative workflow, as in you need to do it a few times and it's never going to be right the first time because of the way that you set up a machine. Another thing is the entry point to this workflow is a bit weird as well, because if you've got a pick and place machine and you've never used it before, there's nothing in the machine, so you've got no loadout. But the next time you go to use the machine, you've got things in the machine and you don't want to take them out unless you really have to. So sort of the entry point is not exactly the same as it would before, because the way you create your assembly variant depends on what's currently in the machine, because you prefer those over ones that aren't in the machine. And we wrote rules to say so. Yeah, it's really weird. So one of the other little diagrams I came up with yesterday, let's see if I can find it. Oh no, it's here already. Was this? And I did this, and I'm like, yeah, there's more to it than this. But you know, this is sort of like a mini little starting point, another little starting point, in that you start with an EDA design, and the first time you use the machine, you've got no loadout. So the assembly variant just uses an empty loadout, which is fine, you know, when you're creating the assembly variant. And then you run some job planning, which is the tool we're trying to build now. And you've got more than one assembly variant if you're placing multiple designs at the same time as well, which further complicates things. And then you do some job planning, but the job planning is sort of like, well, you know, my pick and place machine can't place components that are more than 5mm tall because of the way that the machine is, which is the case with the Charm High machines. So sometimes you have to do some manual placements, right? So they're sort of like processes, the concept of a process, which I'm not sure if I had on my little thing here. Yeah, I'll write that topic here, process. Process. Right, so there's a process. One kind of process would be like placed by pick and place machine A. A manual process might be place tool components by hand. You know, place these components by hand. Another phase and part of the process might be, I guess it's quite similar, is, you know, put the through-hole components on. So in the case where you've got a mixed technology board where you've got through-hole components as well as SMT components, surface mount components, you still want to be able to have all of the parts listed in your parts database system. You need to know when you've used all the parts, you need to have all the stock counts updated, and some of the parts need to get placed by a machine, some of the parts need to get placed manually by hand, right? And then you need to feed back into the system that you've done a particular job. So yeah, so we've got these processes. these processes. So as part of the job planning, there's a phase to process assignment. One thing we touched on a little bit yesterday was that sometimes your pick and place machine doesn't have enough feeders to put all the parts on your board in one go. So for instance, you might have a board which is double-sided and it's got loads of passives on one side and you can't fit them all in your pick and place machine. So you have to split the job up into multiple phases. So one phase might be place this set of components, the next phase, but using the machine, the next phase might be placed, change the reels, place this set of components on the board, and then the next phase might be place the remaining set of components on the board, changing the reels over as you go. Which is, changing the load out of the machine, putting the feeders in there and so on. As in matching the loadout that you want to what's currently in the machine. And then the next phase might be doing the other side of the board in one go. So 4 phases to a job. And then, I don't know, maybe there's a couple of through-hole parts on it, which is your 5th phase or something like that, right? One of the other things that I struggled with previously when trying to work out how to organise what is in the pick and place machine and what needs to be in it and what needs to be in it at each of these phases is exactly which feeders to use for a given phase. And we were talking about this a little bit yesterday in the Discord, and that some feeders are easy to change and are more convenient to change. So on the Charm High machines, the feeders towards the front of the machine are obviously much easier to work with than the feeders at the back of the machine. And due to the way that it has this sort of sliding rod that holds all the reels on the same peeler unit, because they all move around at the same time, due to the way that works, it's you can slide the it's crazy that you have to think of the workflow because of this situation. There's a rod that goes through it, and you can either slide that rod forward or you can slide that rod back. But if you pull it all the way out and then try and put it all the way in again, it's a real pain in the ass because you've got to thread it through the centre of all the reels, but all the reels have dropped slightly, so it doesn't go. So you have to lift each reel up and then push it through, and then lift the next reel up and push it through, and then it's a nightmare. So the reels in the centre have a higher cost of removal, as in it's more fiddly and it takes more time, and we're trying to fix this workflow so that we don't waste time. It's more costly to change the reels in the centre of the machine than it is at the reels at the end of the machine. Sometimes also you might have a reel with sticky glue on the cover tape. So you've got the reel, and it's got the embossed tape, the bit with the holes in it, as in the plastic or the paper part, and then it has a bit of cover that goes across that. And when you peel that cover off, it gets wrapped around a peeler, but before it gets wrapped around this peeler, it goes over a rod, or it goes through other mechanisms or around stuff on different machines. And sometimes this glue is really sticky. So on some machines there's tricks that you can do, which is like put a fold in the tape before it gets pulled round, so that the glue is facing away from the place where it collects on or gets stuck on and things like this. But setting up those feeders and changing feeders where you've got this flip on it is even more of a faff. So that's another high cost of change. So you want to avoid the feeders that are avoid changing the feeders that in your machine. They've got a high cost to change, such as ones that are in the middle or ones that require additional steps to set them up. So you've got a cost to changing a feeder, which is interesting. You also need to know which feeders which feeders are used by other projects, and it's just nightmare. You also need to know which feeders are used by other assembly variants that you're not building like on a given day. So if you know that tomorrow you want to build some other boards, you don't necessarily want to take out all the components that are used by this other board. So there's some cross-referencing, shall we say, that you need to do in order to work out which feeders you should or shouldn't touch, because you're only going to have to touch them again tomorrow, because your time is valuable, right? Oh, it's very hot today. It's baking. Absolutely roasting today. I'll turn the fan up a bit. There we go. That's better. Yeah, so looking at other assembly variants and working out what you don't want to touch, or at least the loadout that you used for that assembly variant. So yeah, that complicates things. I don't know, maybe you need 2 instances of the planning software up, and then you can look at what you used for this one and what your loadout was, and then when you're planning for your new job, you can go, okay, these feeders, I don't want to touch those. Yeah, so what we're going to try and do is sort of to try and get all these thoughts into some cohesive thing that we can write some software for, is to perhaps write down the steps that you need to go through in order to get to the end of this process, right? And then we're going to see what it looks like, I suppose, and maybe draw a little diagram once we've figured it out a little bit. So let's hop into logsec. So workflow planning. So the other day we started coming up with this jobs thing. Can I zoom this? Not really. Okay, I don't know whether this is big enough for everybody to read. It should be okay. It should be okay. If it's not, let me know. And hi everybody in the chat. Let me just quickly read all the chat stuff. Commander Guy says optimize the feeder swapping at some point. Yes, OpenPnP does. It has some functionality in it, but it's a bit sort of all over the place, because it's sort of hacked on, shall we say, only into some feeders. What it does, some feeders have optical character recognition or QR code scanning, and you put a barcode next to a feeder, and then if you want to know what's in your machine, you can run the camera over all the feeders and see what's in there, and have the machine tell you what's in there. But you have to print labels out and all this kind of thing, and on some machines there actually isn't anywhere to even put these labels, and you have to start 3D printing up little flags which you can then print barcodes on and all this kind of stuff for the machine that I've got, which is a faff. In OpenPnP, this feeder swapping thing, it's the way that it's implemented certainly didn't work for my machine. There was issues with the peeler rotation, the way that the peeler was set up, and it was a bit of a mess. But certainly pre-job, one of the pre-job steps, if possible, would be to verify machine loadout. Yes. But yes. Yes, and I'm also trying not to think about the other projects, because I know they don't work for me. So it's like, you can, there's some ideas there, sure. But for this workflow stuff, I'm not looking at the other projects very much at all, because they don't do it right for me. And they certainly, none of them care about the manual placements. None of them care about manual placements. They all the ones I've seen only care about dealing with the machine that you're using to place things. It's literally just pick and place machine software as opposed to workflow software including pick and place machine. And one of the other things I was thinking about yesterday is that if you've got this, let me just go back to this for a moment. If you've got two pick and place machines, and it's feasible, you might have bought one, small one to start with, right? But it doesn't have very many feeders, and then you've gone, well, it'd be nice to have a machine with more feeders, wouldn't it? So you go out there and you buy another pick and place machine, and it turns out the software is rubbish on it, and you've still got your original pick and place machine, which I don't know, maybe it runs OpenPnP or Lightplacer or something like that, right? And then now you've got these two machines with two completely different bits of software on it, and somehow you've got to make these things useful. So it would be fantastic if you could design a job to say this phase of the job uses this machine, this phase of the job is manual placement, this phase of the job uses the other machine, and you can know about all the feeders for all of the machines that you've got. And this is, I don't know, one part of me thinks that that might be going too far, but on the other side of things, it's pretty much exactly the same as having a second pick and place machine as having to manually place components, right? It's no different. It's just like you've got another process, you've got a thing that you need to build, you've got a process which uses one machine, and then you've got another process which uses your hands to place things. And the fact that you're splitting the task up between multiple processes is the same whether you're using another machine or you're using your hands. So I don't. It turns out that it's not too much of a stretch to actually make the planning work with multiple pick and place machines. I don't think. But the planning software obviously doesn't need to know about all the detail about each of the feeders for each of the machine, for instance. It just needs to know which placements should be placed by which process. That's all it's trying to, and the order of those placements. That's what we're trying to do at the moment, which is crazy. It's yeah. It was quite interesting when I thought about that. I'm like, actually, yes, this makes a lot of sense. Yeah. Okay. So back to the list of things that we're trying to do. Okay. So I feel I need a new page. Let's do a new page. Let's say I don't know, job workflow steps or something like this, and we'll see if we can work this out. So I'm just going to write these down, and then we'll reorder them, and yeah. Okay, so you get an EDA tool, great. So make a design in an EDA tool. Yay. Export a list of placements in the EDA tool. Fine, we did all that. Use the variant builder to build a variant, and this is basically I go from EDA name. I'm just going to write dip trace ones, name value, to manufacturer Jura plus manufacturer part number, right? And pick ref deses to place, right? So we wrote that tool, we've got that, nothing's changed there. And the variant builder, one of its things that it can take is a loadout. And if you remember, the loadout items items that we were dealing with, I'll just bring it up. Loadout item. We had this thing called loadout item, and I specifically didn't put, and this is, I was on the money. It's great. I specifically didn't put feeder reference in here, or feeder. I literally just put reference. I'm so happy I did that, because it makes perfect sense for all this. Because obviously if you're manually placing something, there's no feeder. If you've got two pick and place machines, the reference might be machine A feeder 1 or machine B feeder 7, right? Great. So we've got this reference for a loadout. And a machine can have a loadout, which is fine. And when you're manually placing stuff, if you printed out your loadout, right, it will be the list of components that you need to look for in all your parts and stuff. Pull those bags out and put them on the desk next to you so that you can take them out when you need them, right? And that's when you'd use your, I don't know, your interactive bomb viewer to work out which ref des is or which component and so on. Yeah, so going back to this. So use a variant builder to build variant, and you might use existing loadouts to do that. Then you need to decide, I suppose, decide what PCBs load into the, well, not specifically load. I guess it is load, but if we start with like the load into the machine, even though you could use this process for manually placing, if we talk about it from the perspective of the using a pick and place machine, it'd probably make this a little bit easier. So if we decide what PCBs to load into the machine. I don't know if you're doing, say, manual placement, maybe you want to place like 4 boards at the same time, right? So, you know, you've got your desk in front of you, and you've got bags of components, and you've got to put the same component onto 4 boards, right? So decide what PCBs to load into the machine or place on your desk. Right. And then let's have an example. E.g., 2 panels and say 2 singles. Because maybe you popped out a couple of singles from a panel. Right? Fine, whatever. Doesn't matter. And they could be the same type of PCB design, or they could be 2 different ones. Okay, so, and then the next thing to do is decide well, perhaps this goes up here, actually. It probably does, doesn't it? I don't know. Maybe it goes. Yeah. Let's say make designs in an EDA tool. Export a list of placement for each design. Yeah, okay. So if you've got a panel that's got 2 designs on it, for instance, you would make 2 designs, you get the panel fabbed and they come back, or you make 2 designs, you ship them off, and maybe both of these designs use all the same components, but they're a different physical form factor, you know. Who knows what your reasons are, but you've got your reasons. So you've got multiple designs, and each design can have multiple variants. Maybe you want to try different resistors to change the intensity of the LEDs or something like this. So you've got your variants, right. So use the variant to build a variant, to build, yeah, okay, decide what PCB. So, no, we're not quite there yet. It turns out that you need to decide which variants you want to assemble. Right. Then use the variant builder to build the variants for each design. So now you might have multiple variants created. Right. Then let's deal with the difference. We can reorder this stuff. Let's deal with the panelization thing that we tried to do the other day and then completely got unstuck on because we realized all this stuff. Let's define a panel size, and then we'll say size, rails, fiducials, and size, rails, fiducials, and then how many of each design are on it. Design origins. So let's say designs and their origins. And we're not talking about assembly variants, we're talking about the design. Right. Because one of the PCBs that you put on your desk might be a panel, and the other one might be a single, and it might have come from another panel. And you just stuck it to the embedded machine with double-sided sticky tape. Away you go. But it's not in a panel anymore. Right. Then what have we got? Let's bring up this for a moment and think about it. Yes. Yeah. So I wrote units down here. So let me see if I can fit that into here. Define a panel. Design units and their origins. This is what I'm calling them on the PCB. It's a panel has a bunch of units, as in it might have 10 units. Unit 1 might be for design 1, unit 2 might be for design 2. But they're numbered and they've got like coordinates to them. Yeah, okay. That's what units was about, right? So variants, EDA, jobs. So we've sort of dealt with this stuff at the moment, right? And we've also dealt with this a bit as well, actually. Sort of that. That's where we're at right now. And I guess we dealt with some parts as well a little bit, but there's more of that to come. Right. Let's say that you know before you're making these boards that you know you're dealing with through-hole components as well as SMT components. So you can decide which processes to use, e.g. PnP machine 1 plus manual placements. This is common. Right. Yeah. Okay, let's switch back to this. Let's see if I can jog my memory. Right. So yeah, so we say with EDA and we've got assembly variant, you're right, and then we've got a yeah, okay. Yeah. Now. Yeah, okay. So you have to somehow assign, I guess it's assign parts to a process. Do you? Okay, so if you've got like a tool part or a through hole part, the tool part doesn't fit in your pick and place machine, fine. Or maybe it's just too big for the pick and place machine's camera or whatever, so you need to manually place it. The through hole parts your pick and place machine can't place anyway, right? So you have to say, for these parts, I want to use this process. Let's write that down. So I'm not sure where it fits in all this. Decide which parts for the, I don't know, let's say the overall thing we're trying to do is a job. For the, and it's an assembly job, but I don't want to keep writing the word assembly all the time. Decide which parts for the job yeah. Decide the process to be used for each part in the job. Right. And how can you do that? Like, easily? Yeah. So you could set up rules, for instance. Automate. Let's say automate using rules, e.g. SMT parts are through hole parts are always yeah, tool parts use second machine or whatever, you know, or are manually placed or whatever these rules are, right? And you can fairly easily automate some of this, and then everything else just is like pick and place machine 1, done. Right. Yeah. And then I guess if you look at the loadout to be used, yeah. Loadouts. How do we decide the process for each? Maybe Maybe this is in fact deciding the loadout for each process. Let's change it to that. Well, no, because you need the loadout for the thing, for the process. Oh my gosh. If you, what about? Okay, and then, yeah, let's just say, how about we say assign loadout okay, let me just bring this back like this for a moment, and then let's say assign a loadout to each. Well, okay, sort of. Yeah, okay, this is where it becomes sort of iterative. Assign a loadout to each process. Add, I guess it's assign parts to loadouts, and that can be automated using rules. And yeah, because this is one of the trickier bits. Yeah, okay. The problem then comes is that if you've done all this, you've basically got your process, which is, let's a simple example, where you've got a board which has got too many parts to do in one go on the machine, right? So you go, okay, I'm assigning all of the parts for the assembly variant that I'm going to build to this loadout, and then you try and assign feeders, I suppose, to the loadout, as in you try and fill out this reference, right? That part of the process. At some point you're going to get stuck because your machine doesn't have enough feeders. Let's write that down for a moment. Assign feeders to loadout items. Write that down, right? And then at some point, yeah, you run out of feeders. You go, damn it, I can't fit them all. So then you go, okay, add another phase. Add let's say and let's say create a phase for each process up here. And then let's say you run out of feeders, so you go, okay, I'm going to create additional phases and loadouts if you run out of feeders on the machine. Right, and then essentially sort of you go from here back up to here again, right? And then you go, okay, well, this part needs to be in the second phase for this job. Yeah, okay. Good Lord. Right, then what? So at this point you've got your, oh, wait, hold on. And then in order to, what do we need in order to do this? These things: assign loadout, assign parts, define a panel, design the process. Right, we missed a step here. Which is define the variants for each, and let's say unit, for each unit, as in a panels unit or a single PCB. They're both units of stuff that you need to assign a variant to, right? Maybe we should say assign variants. Yeah, assign variants to each PCB unit, e.g. panel A unit 2 is design A variant C. I'm just going to put a 6 here. Right, so you do that for each, and you go and you do the same for the other ones, but there might be more than one panel on the machine or on your desk, right? So if you said panel A instance 1, unit 6 is this, and then you go oh, I don't, jeebus. Yeah, we'll do. I'll just write it on this for now. The first type of panel A, the 6th unit on it is design A variant C, right? And then maybe you've got a couple of PCBs that you pushed out of a panel, and now they're just like laying flat on the desk or on the bed of the pick and place machine. You want to go, all right, I want to place those as well. But say you've got 2 of them on your desk, right? So you might say single one is design a variant B, perhaps, right, etc. Perhaps it might be useful if we drew a little diagram for this to illustrate what I'm thinking. Open recent, sketch template, save as. Where are we? That one. Design, workflow. PCB variant assignment. Right. So let's just say the bed of your machine or your desk has got a panel and another panel. It's not a very good box, was it? And I don't understand this program sometimes. It just like, why? I was looking for a setting in this, like, to sort of make it change the resolution. Like, it drew... Whatever. Anyway. Right. And then you say, inside this panel... And again, it's drawing it in the wrong colour here. Why? Just... Okay. It'll just have to do. Okay, I'm going to use different colours for this. Yeah. Hold on. Now there is a way of changing the colour for this. Is it this? Yeah. That's still not the right colour though. I don't know which orange I used. Who? Oh dear. Oh dear. Oh no. What is going on here now? Okay, fine. I'm just trying to use the same colours everywhere, otherwise it's just going to be annoying. We're going to use that one next to the yellow. Right, fine. Right, and then we're going to say, right, we want some pink ones. I don't know, maybe I should just use the square tool and everything will be fine, right? Fine. Yeah, let's just do that. Right, and then this one is going to be one of these. Right. Sorry, the my OCD is getting to me a little bit. Righto. And then we're going to get rid of this one. We're going to pick another colour. Let's use yellow. Sure. Right. It's sort of snapping to it, isn't it? Yeah. Right. You know, our bad panels. Oh, and we need another yellow one. Right. This is our sort of hypothetical example of what's on your desk. I guess this box should be the same size as this box, really, shouldn't it? Otherwise it's a bit confusing. How do I pick this? There we go. Oh, I'm a bit of a noob with this program. You'll have to... How do you rotate it? Rotate, transform, here we go, rotate. Yeah, that'll do. Fine, whatever. Save. So this is sort of the scenario, you know, that you could be dealing with, is in that you've got like some panels which contain some designs, and you've pulled 3 of them out, but you still want to assemble these today, and you've also got to assemble these panels. Each of these panels, you're doing 2 of the panels, and you want these 2, as in Unit 1, Unit 2, Unit 3, Unit 4. Let's mark these up. Let's do it in green. Oh, how do you draw text? Anybody know? No. Oh, what the hell is this? Jeez. You have to draw a box for it. Oh, I see. 1, I suppose. Fine. Right. It's not very easy, is it? Two. You know, you get the idea. Can we? Oh, I see. Right. Okay. So we can leave that out. No, you can't leave it out. Right. You have to click close. Fine. So you know, 1, 2, 3, 4, 5, 6. You know, those are the unit numbers, right? And then these things here, you need to. These are essentially as singles, and they need their own. There's instances of these, and at some point you'll say to the if they were in a pick and place machine, you would tell the machine where they were and their orientation and so on, and do all that calibration malarkey. But you don't care about that too much. You just care about that there are these things that you want to place, and you're trying to create a job, and you need to know how many components you've got, and if you've got enough stock to do it, and which order you need to place them in, and all the rest of it. And exactly what goes where. Right, so we've got to do that. So that's our sort of idea of, you know, a layout, desk layout or bed layout or whatever. Right. Right. I suppose also what we need to think about is are we thinking about job repetitions is what I'm thinking, I suppose. That's probably how to say it. So say you've got a pick and place machine, and you want to build 6 of these things, and you're only doing 1 of them at a time. Is the output of a phase a list of placements, right? And then you take your placements and then you feed that into the machine, but your job planning is still the same regardless of how many times you do it, right? Because you still need to load the machine up. Ooh, that complicates it, doesn't it? That complicates it. Dear me. Because say you've got one... The scenario where you don't have enough feeders in your machine is a nightmare scenario. Because on that given day, you have to paste up a board and then put some parts on it. And then paste up another board and then put some parts on it. And then paste up another board and put some parts on it. And you get your machine to put the parts on it, right? So at any given time, you've got a board that's not fully populated, and you have to take it out, put it somewhere, change all the stuff on the machine, and then get that first board and put it back in the machine again, and then run the second process on that board, which is using the same machine with a different loadout to put more parts on that board. Then you take it out, then you get the second board that you had earlier, and you put that in, and then you have it put more parts on it on the second phase of it. So how does this change things? So I suppose you need to know a removal. It's sort of like a step of the process, like a removal step and a reinsertion step, or something like this, right? Okay. This is a nightmare. This is just a nightmare. There's just so many different ways that so many different scenarios that you've got to deal with. Let's go back to my list of things that can happen mid-job. How to stock if a component or reel runs out. This is what I'm thinking about at the moment. So if you've designed your assembly variant and you've said this assembly variant is going to use this part, and then you know that you don't have much of this part, or perhaps you don't know that you don't have much of this part, right? So the first batch of assembly variants are going to use maybe old stock or something like this, right? And then you're going to transition to using a new part. But all the rest of the components for it are the same, but you still need to get rid of these old parts, right? Or, yeah, you just need to use the old parts first, right? It's pretty common. But how does that affect the workflow steps? Because you want to say, okay, I want to do this process a bunch of times, and one part of the process might be laying out an entire panel, but you get to the say you get to the third unit, and now you're out of stock of the part that's going to go on this one, right? And then so now you need to use a different part for this while you're still running this job. Oh gosh. Potentially you could put both reels in the machine when you're doing it, and not even yeah, if you did that would be okay. Oh, dearie me. Nightmare. Yeah. Okay. Okay. Let's try and go back to the steps. I think my mind is wandering a little bit. Right. Create additional phases and loadouts if you run out of feeders on the machine, which is fine. Right. Let's look at this for a moment. So have we captured this in our list of steps? I think we have. We've decided the processes. We've done the part to feeder assignments. Okay, so assign feeders to loadout items. Yeah. I'm just thinking about the you've assigned parts to feeders, you've created feeders, yeah, and then you go back to assigning parts to loadouts again, right? Where in this does sort of like the iteration happen? Decide the process, and I mentioned sort of the amount of times that you want to run the job. So decide what PCBs to load into the machine. Okay, let's say up all the way at the top here, decide how many times to run all of the processes. Right. Right. So how many times do you want to put one panel in the machine and have it place parts? Which is sort of like the normal way. Right. Now what's it got to do? What's it got to do? It's got to give you what artifacts are there? What artifacts from this process are there? Let's talk about the artifacts for a moment. Maybe that'll help us. Artifacts. So list of phases, because the other day we talked about sub job, but this I think it's like a phase. I guess it's a list of operations. Let's say a list of operations. What's an operation? Feeders to load, PCBs to list of operations. Let's say a list of phases. Is that right? Yeah. Put a phase for each process. List of phases. List of operations for each phase. PCBs to load. Because remember, you have if you're repeating the job multiple times, the same phase gets run multiple times. At the start of that phase, you have to put the PCBs in the machine for that phase, right? And then you have to put all the parts in the machine for that phase, and then you run that phase, and then at the end of that phase, you take the PCB out, you put it somewhere else, you get the next PCB, and you put it in, and then you run the same phase again. And the feeders will already be loaded at that point for that phase. So I guess a list of phases and repetitions for each phase. Yeah. So you run phase 1 3 times, then phase 2 3 times, then phase 3 3 times, phase 4 bottom of the PCB 3 times. Then you do some phase 5 manual placements and you solder them in by hand. Yes, that works. E.g. I'm going to skip the example here. Artifacts. I guess one of the most important artifacts is what parts to actually put on the PCB in this phase. And this is a list of placements, but it's an ordered list of placements. Let's order list phase for each phase. Let's do that as a separate thing by itself, as opposed to being an operation. It's not an operation. Ordered list of placements for each phase. I think we're starting to get a clearer picture of what it is that we need to build at this point, which is good. This is what I hoped would come out of my ramblings today. Man, there's a lot to think about here. How are we going to do all this? Yeah, okay, so order list of placements for each phase. Hold on. So the feeders to load. Wait a second. We've got assigning parts. Well, we said we want to assign parts to loadouts automatically, right? So the first time you run this, everything gets assigned to one loadout, and then you try assigning feeders to the loadout and you realise you don't have enough, so then you have to run it again. But it uses the loadout that you've already defined and then tries to work with that, I suppose. Assign parts loadout. So I guess let's say part to loadout assignment. Yeah. And I imagine that there's going to be some kind of status. As in, everything's fine. You've done all the things that you need to do. You've assigned all the feeders to parts as a reference for each thing in the loadout, and all the parts are accounted for, and so on. What about so we have to start somewhere with all this, is what I'm thinking. Like, well, the problem that I was thinking about a bit ago, whereas, you know, you've got this job, and you wanna start on it, and then you run out of a part mid-job. That's what I'm concerned about a little bit at this point. How do we fix a job once we've defined it to have a different part if we find there's a problem with some part or something like this? How do we update the job to say use a different feeder mid-job? How do we recreate the ordered list of placements ordered list of placements? Yeah, we've got this. There's more to it than this. We've got this ordered list of placement. Yes, it's true. But what we need to say for each placement, we need the source for that part. Because we've got the destination of it, that's fine. We know where it's going to put it on the PCB, which is fine. Order list of placements for each part. And the source for each placement, aka feeder. Let's say, i.e., where to pick from and where to place. Hey, pick and place. Right, so we could potentially deal with using a new feeder if you know that you're going to run out of stock initially, and you can tell it to put it in the machine already. Yeah, it's possible to do it. Do we want this? Yeah, I suppose we do, don't we? Now, if each of these placements was ordered, right, and you want to change something mid-job, oh dear me, it's just... changing stuff mid-job, not an easy problem to solve. Okay, let's. I'm going to get brain blocked on that if I keep thinking about that too much. So what else? What else? We've got status. Ordered list of placements for each thing and the source for each placement. Blah 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 blah. Right. And then if we want to, yeah. I'm thinking about stock levels right now. Like, if you say I want to run it 20 times, and you know that you don't have enough parts, or the system knows that you don't have enough parts to run it 20 times, it should be able to tell you. At which point you would go back to where you'd go back to your job repetitions and you would adjust it, right, and then you'd just go, okay, refresh, right. Do we have enough information there? Let's look at our little word cloud. Okay, what do we got? We haven't talked about change cost. And we haven't talked much about ordering. Let's think about these two for a moment. Change cost and ordering. So we've got this order list of placements. Right. Order list of placements. Now. What are we doing here? There are various different. I don't think I really need to go into it too much on this, because it's fairly self-contained. Placements need to be ordered normally by cost, size, and so on. Normally when you're doing pick and placing, you want to place one of your cheapest, smallest components first. The reason for that is so that you get your accuracy correct at the start of the job, and not realise after placing some large components on some large solder pads that your accuracy for your 0402s is bad and it's way off, but your accuracy for your 1206s, it was accurate enough. Yeah, so the ordering. So I don't think we really need to go into ordering, but there does need to be some ordering. Okay, how about we say choose ordering for choose placement ordering for each phase, e.g. sort by cost, area. I'm just going to say lowest cost. Oh, that's interesting. Smallest area and lowest height. And if you don't know the cost, then area and height is normally okay. Yeah. And maybe remaining quantity sort of sits somewhere here. I don't know. There's various different ways of doing it, but you need to choose it somehow. and it could just be as simple as having the list, and it's automatically in the last order that you picked when you create the new phase or whatever, and then you can adjust it by either dragging and dropping, or seeing a thing and then pressing up, down next to it, or maybe applying some rules. So there's loads of different ways you can do that, but the details of which aren't important. Just the fact that some placement ordering needs to be chosen. Yeah. Then what? Then what? Artifacts. And then if you're, let's think about the case where the status was good and everything is fine, and that you've managed to assign all of your parts to all of your feeders, and you're only doing it once, and you've only got one phase, and everything's happy, right? Status is good. So at that point, what would you do with the artifacts? Yeah, let's think about that for a moment. So you've got your order list of placements, your list of operations, your part to load out assignments, and your list of phases. Yeah, this is more interesting. And now we're into sort of like running a job sort of territory. So like, how do you begin this? I think that's probably a topic for another page, like running a job with the artifacts that you've got, and then maybe rerunning this process and resuming a job. But I could basically see it the way you've got, if you're doing, say you're doing a manual placement, it would say phase 1. Repeat once. Here's the loadout. Here's the list of parts that you need, right? And it's if it was manual placement, it would say feeders to load, and if you were manually placing, it would say desk part X, desk part X, part Y, sorry, desk part Z, or whatever. Right, and you get it and you put it on the desk, it's fine. Right? And then it would tell you which PCB you need to get, like PCB 1. Great, I put it on my desk. And then I've got an ordered list of placements to do, and I follow it, and I go, oh, it wants me to put R1 first, and then I get my interactive bomb viewer, and I find R1, and I see where it's supposed to be put, and I get my tweezers, and I get the part, and I put it on it. Okay, and then I repeat that for the remaining order list of placements, and I'm done. So that's how it would work for like manual placement. If you're doing it for a pick and place machine, obviously it's going to be different. Somehow you need to take your ordered list of placements and somehow why did it do this? I don't know. Okay, that's weird. Can we put this in code? Yeah. Somehow you need to take your ordered list of placements and I'm thinking about the panel. There's more artifacts, isn't there? because we've got this, there's an artifact missing for a pick and place machine, because the pick and place machine is going to need to know about fiducials for a panel and things like that, right? So there's more artifacts. Let's think about that for a moment. Define a panel. Yeah. And how does one sort of phase feed into the next one as well? That gets tricky. But I guess that's down to the implementation of the pick and place machine, sort of like job processor, in that when you're doing the next phase or whatever, it uses the same place where the last panel was put for the next one. Yeah. Okay. So list of phase and repetition for each phase. Part load outside. List of PCBs to load. And I guess, let's say, panel let's put the panel specification in the list of artifacts, because, or is it just an input that appears that it just gets reused? Because you've got this panel definition up here. Is it an artifact? I think it's just something that just gets reused if you need it. I'm going to delete it from there for the moment. The other thing I was thinking that you need is to know which panel and which PCB unit is using which variant, because we've decided it up here somehow, but it needs to be in your list so that when you've got your list, you've got something that you can work from. Yeah, so I suppose it does make sense to have. Yeah. Panel definitions. I'm going to put it here. Assembly variant to PCB unit list. You're going to need that in order to. You don't need it to run the job, right? But you need it to have an overview of what it is that you're supposed to be doing. So if you're manually placing it, you go, oh, I'm doing this one's variant 3 over here. Fine, okay, right. I'll remember that. I might not need that information while I'm just placing it, while I'm placing the individual components, or while the pick and place machine is placing the components. But for like an overview of what's happening, you need it. And this is the same with the panel definitions. If you're manually placing, you don't care about like where the fiducials are on a panel. You just don't care. But But if you're feeding all this artifacts into a pick and place machine, the pick and place machine is going to need to care, because it needs to know about all the origins and so on. And this ordered list of placements, now, if you're manually placing stuff, if you're manually placing a panel, the way you do it, the ordering, is completely different from how you might do it on a pick and place machine. If you're manually placing it, you want to touch each bag of components the fewest amount of times. Okay, this placement ordering is slightly more complicated than this for the differences. So if the goal is to touch each bag as few times as possible. Oh yeah, and then one of the other ways is feeder reference. Yeah. If you're manually placing it, right? Let's just expand this a bit. This is actually important. So PnP machine would sort like this. Manual place would sort by part, probably, yeah, part. But you know, sort of. Let's just say area first, smallest area first, lowest component first, then part, right? But what we're missing from here is the unit. So you would place the same part on one PCB unit, as in you would place the same part on this one, and then you would place the next part on this one, this unit, and then the next part on this one, and then the next part on this one, and then you move to the next one of these, and then you do the next one, following the same order. So PCB unit makes up is part of the ordering. So it's like PCB unit, and then cost, then area, then whatever, right? But for manual place, you put PCB unit later, and if you were manually placing this, you would get part one, and you would put one of them on this one, then you would put one of them on this one, and then one of them on this one, then one of them on this one, and then one of them on this one, and then you would not touch that bag of parts again. And then you would go back to the first one, and then you put the next part goes on this one, then this one, then this one, then this one, then this one. And you could probably start with cost here as well. So you do the cheapest, smallest, shortest one, and you put the same part on each PCB unit. But for a pick and place machine, you don't do it that way. The ordering is different. Okay, this is good. That's interesting. Okay, good. Yeah, okay. So this where to pick from and where to place. Yeah, needs to contain like the PCB unit. Feeder to PCB unit ref des. Something like that, you know. And obviously, if you're dealing with a pick and place machine, then you've got the rotation of it and all this kind of stuff as well. And if you're manually placing, then, you know, sure, you might have like you would have the details of how it is rotated in the EDA design here, but you but as part of running the job, the final rotation will be decided. Yes, I think that's correct. Yeah. Right. Okay. Is there anything else we've not talked about yet? Change cost. We haven't done change cost yet. Let's have a think about change cost. Assign feeders to loadout items. Yeah. Like how? So as part of this, we've got this feeders to load thing, right? I'm just going to write that like that. Assign feeders to loadout items. So this is one of the problem areas. This is one of the problem areas. Right. How can we automate assigning feeders to loadout items? Well, automate. I'm just going to say automate using rules, e.g. current machine loadout, right? So yeah, I suppose you can use it as some sort of source of reference, right? initial population from current machine owner. Let's say that, because you wouldn't want to do this more than once, because then, you know, it's an iterative process where you go back and you go, no, I need to use that feeder for something else. And I guess you could say feeder not used by other variant. Feeders not used by the variants. That's the way you go, right, today I'm building this, but tomorrow I'm building this. So I want to say to the software, no, I'm building this tomorrow. Try and avoid upsetting my machine too much. And there's probably a bunch of other things going on here. Right. Feeders not used by other variants. Oh yeah, and then the change cost as well. And perhaps this is just a form of change cost, as in it's the more other designs that use this feeder, the higher the change cost there is on this. I don't know. Maybe that has a weight or something. There's some kind of weighting or something. I don't know. Let's write change cost, and then let's just write down some of the reasons for a change cost. Let's write low. Feeders that are hard to change, high cost. Yeah. Empty feeders, low. Zero, perhaps. I don't know. Maybe just add all these things up, you know. And you know, maybe you've got a hot swap thing, and they're all really easy to change or whatever, you know. And that way, you know, there's no sort of weights for these things. Yeah. Yeah. And then what I'm thinking about now is that you've got like real feeders, and then you've got tray feeders, and then you've got loose part feeders. Yeah. There's probably a bit more to this. You can probably sort of automate this more over time, but I think like initially we can probably sort of say that, you know, it's a manual process, or maybe you just order by this, select a bunch of parts, and then I don't know, or just maybe you just manually do it to start with. for ones that don't exist in the existing loadout, right? Because you could iteratively build this change cost stuff onto what it is that we're building. I don't think we need to worry about all this automation stuff too much. Just the fact that we need to do this as part of the workflow. And again, it's the same. It's the same with this one as well. Yeah. Yeah. So I've got a good list there now. I'm a bit happier with where we're at. Where we're at. Right. Okay. Right. I think I'm going to take a break from this. I need to digest all this stuff and get a drink. My throat is killing me. All this talking. Right. Okay, so we've not written any code today. I don't know. Maybe I'll write some this afternoon. We'll see. Probably will. I'll try and have a go at some of this. Yeah, okay. So just remember, folks, it's only software. How hard can it be? We'll find out